Welcome back to the podcast, where we dive into the complexities of data management and technology. I'm your host, and today we're exploring the intriguing realm of data models and querying languages. If you've ever been curious about how data is structured and accessed in different applications, you're in the right place. Let's set the scene. At the core of any software application is a data model, which serves as a blueprint for how data is organized and accessed. This is crucial because a data model affects not just how efficiently we can store and retrieve data, but it also shapes the types of applications we can develop. Today, we'll take a closer look at three major data models: the relational model, the document model, and graph-based models. We'll also discuss the various querying languages that go hand in hand with these models. So, let's dive in. First up is the relational model, which was introduced by Edgar Codd in 1970. Imagine data organized into tables, where each table consists of rows and columns. This model quickly gained popularity and became the standard for data storage and querying, especially with the rise of relational database management systems, or RDBMSs, in the mid-1980s. Why did it become such a hit? It provided a clean and intuitive interface for interacting with data while concealing the complexities of internal data storage. This was revolutionary for transaction processing and batch processing, which were the main use cases at the time. Think sales transactions, airline reservations, and payroll systems. For nearly 30 years, relational databases reigned supreme. But as technology advanced, so did the demands of developers and businesses. Then came the NoSQL movement in the 2010s. Now, the term NoSQL can be a bit misleading. It started as a catchy hashtag for a meetup about open-source distributed databases, but quickly evolved into a broad category of database technologies aimed at addressing some of the limitations of relational databases. So what drove this shift? Several key factors played a role. First, scalability became a major concern as data volumes skyrocketed. And relational databases struggled to meet the demands for handling large datasets and high write throughput. Additionally, developers began to favor open-source solutions over commercial products. Many applications also required query operations that relational databases didn't support well, and developers were frustrated with the rigid schemas of those databases, leading to a desire for more flexible and expressive data models. This brings us to the document model, which emerged as a response to the limitations of relational databases, particularly when it came to handling complex data structures. Document-oriented databases like MongoDB and CouchDB allow for a more flexible format, often using JSON. Picture this. If you were building a user profile for a platform like LinkedIn, a relational database would require multiple tables to represent a user's information, job history, education, and contact details, resulting in complex queries and joins. In contrast, with a document model, you can encapsulate all that information in a single JSON document. This not only simplifies data retrieval, but also makes the structure more intuitive. A user's profile can be represented in one neat JSON object, allowing you to fetch all relevant data with a single query. However, it's not all smooth sailing with document models. While they offer flexibility, they can pose challenges, especially regarding data integrity and consistency. Without a strict schema, it's easy to end up with messy data if not managed carefully. This leads us to the concept of impedance mismatch, which describes the disconnect between object-oriented programming languages and the relational model's tabular structure. To bridge this gap, developers often use object relational mapping, ORN frameworks, which help translate between the two models. While these frameworks reduce boilerplate code, they can't completely eliminate the inherent differences. Now, let's take a quick look at graph-based models. These models are particularly effective for applications that require complex relationships and connections, such as social networks or recommendation systems. Graph databases store data in nodes and edges, making it easy to traverse relationships and perform queries based on connections. For instance, if you wanted to find friends of friends in a social network, a graph database can efficiently retrieve that information without the complex joins required in a relational model. As we wrap up our discussion, it's clear that there's no one-size-fits-all solution when it comes to data models. Each model has its strengths and weaknesses, and the best choice often depends on the specific use case. In today's diverse data landscape, we're likely to continue seeing a coexistence of relational databases alongside various non-relational data stores. This approach, known as polyglot persistence, allows developers to leverage the strengths of different data models to meet their application needs. To sum it all up, understanding data models is essential for anyone involved in software development. Whether you're working with relational databases, document stores, or graph databases, each model offers unique capabilities that can influence how you build and optimize your applications. Thanks for tuning in to this episode. If you enjoyed our discussion, don't forget to subscribe and share this podcast with your fellow tech enthusiasts. Until next time. Keep exploring the fascinating world of data.